Hello and welcome to our January webinar. Today we've got a pretty exciting topic that's been gaining a lot of interest lately. So we're going to be talking about ductless heat pumps, the system types and their controls. I am joined today by Nick Young from the Association for Energy Affordability, and he will be the presenter today. As usual, just a few housekeeping notes and instructions on how to use GoToWebinar. Today's webinar is going to be recorded and available on the program website within a few days. So if you want to go back and reference this webinar and training, or if there's anybody in your organization that you would like to share this webinar with, please go check it out on our website or reach out to me directly and I can send you an email, a link in email. All attendees are currently in listen-only mode. If you'd like to ask a question, just please use the question box on the GoToWebinar panel, and I will be moderating and taking questions and passing them along to Nick at certain points in the presentation. But at the end of the training, we'll open the audio line for questions. So in order to participate in the discussion at that time, please just enter your audio pin located on the sender panel of the screen and raise your hand, and then I can unmute you. As a reminder, we do the trainings all year long, usually once a month. So there's always something coming up. Our next one's going to be in February, on February 27th, again at noon, and that's going to be all about high performance ventilation. So if you have any interest in that, please go online now and register. And a good way of staying up to date on any webinars and trainings that are coming up or any program updates and announcements, those can be readily found on our newsletter. So please register for that. There's a lot of good content in there. So a little bit about the trainer. As I said, today we're joined by Nick Young. He's a fantastic presenter, and he's with the Association for Energy Affordability. As a trainer, Nick enjoys helping demystify technical concepts and giving people the tools and confidence to use different approaches that can improve buildings and reduce environmental impacts. He firmly believes that strategies to address the housing and climate crisis are complementary, not competing. AEA is dedicated to preserving safe, healthy, and affordable housing and reducing climate impacts through energy efficiency and building decarbonization. They're also very happy to partner with programs like ORMEP that share similar goals. And as a reminder for context of why we're putting on this webinar and the other webinars like this, is that OHCS's multifamily energy program provides incentives for energy efficiency measures that result in electric savings. These savings can come from a variety of different measures, many of which have been covered in past webinars and presentations or upcoming presentations. But today we're focusing on just the integration of efficient heating and cooling systems in the form of ductless heat pumps. As I said in the beginning, we're seeing an increased interest in using these DHP systems. So hopefully we can use this hour to answer some of your questions that may have come up just about the different types, their usage, and the variety of controls that come along with different systems. And with that, that's my spiel, and I can hand it over to Nick, and he will take you through the rest of the presentation. It's all yours, Nick.
Great, thanks, Matthew. Yeah, so real quickly, the agenda, we're going to start with basics of heat pumps, then talk through the different ductless heat pump system types. We're going to go through quite a few of them, and then touch on the different kinds of controls that you can have for these ductless heat pumps. So we're going to start with heat pump basics. And often when folks are sort of first jumping into this technology, the question comes up, like, what exactly is a heat pump? And a heat pump, very simply, is something that moves heat from one place to another. So we're familiar with products that do this. Your refrigerator moves heat from inside the refrigerator to your kitchen. A water fountain that dispenses cold water is having to transfer that heat from the water to cool it down into the surrounding air. And heat pumps do the same thing. They're moving heat. So next time you're asked what is a heat pump by someone, or if it comes up, you can just tell them it's something that moves heat from one place to another using refrigerant, just like an air conditioner or refrigerator. The technical way that this happens is through the refrigerant cycle. And I'm not going to jump into this in too much detail right now, but this is the cycle that's used in all heat pumps and air conditioners. They all have a compressor, they all have refrigerant flowing through them, an evaporator, a condenser. And there's lots of resources available online if you're interested in digging into what exactly is the refrigerant cycle and how it works. But this is a basic overview of what's happening inside of any system that uses the vapor compression cycle with refrigerant to move heat around. So let's move on to the real benefits of heat pumps, particularly versus electric resistance, which is sort of the most popular or sort of most commonly thought of heating type in Oregon and the ORMAP program. So a major benefit of heat pumps is they're much higher efficiency than electric resistance. Heat pumps operate at around 2 to 5 times the efficiency of electric resistance systems, which can significantly lower heating costs, particularly in existing buildings or in retrofits. Maybe the insulation values or the envelope isn't quite as good. If we're able to use a heat pump, it's gonna significantly reduce bills, either for tenants if they're the ones paying them, or for the owner if it's paid by the owner. They also provide cooling and dehumidification. So remember, a heat pump works the same as an air conditioner. And the nice thing is that they can switch directions. So in the summer, a heat pump will essentially be an air conditioner, moving heat from inside the home to outside, cooling down the home or the apartment. And in the winter, they switch directions and they pull heat from the outside air, they extract heat, and they put it inside. And so they work in both directions. So when there are heat waves, which we now know that we are having to face all over the West Coast in areas where we might have been able to get away with not having any air conditioning for a long time, you'll have cooling. So a heat pump system in one unit can provide heating, cooling, and dehumidification, which can be a real benefit. So that's heat pumps. What is a ductless heat pump? That's the real focus of our session today. A ductless heat pump, very simply, is a heat pump unit that does not use ductwork. And they largely fall into 2 categories. Either packaged systems, which we have on the left, where all of the refrigerant containing components are all in one piece. They're in one box. Or split systems, which we have a depiction of on the right-hand side. And a split system is going to consist of an indoor unit, or sometimes many indoor units, and then some sort of outdoor unit. And you're going to have refrigerant running. Most of the time, you're going to have refrigerant running between them. So that's real. Like, everything is all self-contained in a package system, and then the systems are split apart in split systems, and we'll see examples of each of these. So what are some of the benefits of now a ductless heat pump system? One is that they can have lower installation costs, particularly than a ducted heat pump, right? Since we don't have any ductwork, we don't have to deal with the associated installation or design costs of that ductwork, or the softening and all the stuff that goes along with it. There won't be any HERS duct testing that's required since we don't have ductwork. And often refrigerant in these systems is factory charged, so there's no HERS refrigerant charge testing for those system types. Ductless heat pumps can also be extremely high efficiency because partly they eliminate duct losses. There are a lot of energy losses associated with ductwork. That's part of the reason ducts have to be tested, because ducts leak. So if you eliminate ductwork, you eliminate duct losses, which significantly improves system efficiency. And then furthermore, inverter-driven systems can vary their speed to match load, and we'll see some examples of those types of systems. And so you can get very, very high efficiencies. Another benefit of ductless heat pump systems is you have a lot of flexibility in terms of design and operation. Ductless split systems in particular can be located almost anywhere. And many of these systems can have different set points per room, or only heat and cool one room at a time if desired. So this is a depiction of a single family home, but you could imagine this to be a multi-bedroom apartment. And they have got one room at 76, one at 72, one at 73, one that's off, right? This one's off down here. And they've got the heat pump outdoor unit that's supplying the refrigerant to each of these indoor units, each of which has its own set point. So you can really, you can see how this can really minimize energy usage, because you're only using exactly what you need. If you're heating, you're only heating to exactly what you need or want, where you want it, and same for cooling. Maybe, especially for cooling, a lot of times when you need cooling is like in the evening or when you go to sleep and the apartment is still hot, right? Because it was a hot day and it hasn't cooled off yet. You can just cool the bedroom and cool it just enough, and then it's fine. You're not having to cool the entire apartment. So this ability to deliver specific set points per room can be a real benefit. So we've got a question break here. Are there any questions that have come up?
Yeah, I had one just pop up a second ago about that room by room control. Um, is that how is there an individual control for each bedroom to change those set points, or is it controlled through one central control?
Usually, for room by room control, you will have a controller in each room. So each indoor unit will have its own remote control or its own thermostat. And we'll get to the controls later and see some examples of these. But yes, you would generally. I think there are some more sophisticated central controls where you can dial in the set points in each room. But usually, it's an approach where the indoor unit has a remote that's operating that indoor unit. So whoever's in that room can control the temperature.
Okay, great.
All right. So let's talk through some of the different ductless heat pump system types. So just remember we mentioned packaged and split systems. So within packaged systems, we have three main system types we're going to look at today. We have packaged terminal heat pumps, or PTHPs. We have vertical terminal heat pumps, which are similar but slightly different, and we'll look at it. And then a room heat pump, or AC. Now, on the split system side, we have largely two major system types: ductless mini splits and variable refrigerant flow, or VRF systems. So we're going to see examples of each of these and talk through the specific sort of key ideas for each of these different types of systems. Starting with package systems. So sort of the most basic, low-cost ductless heat pump system, or low first cost, low install cost, is going to be a package terminal heat pump, or PTHP. These are entirely self-contained. You've got the through-wall unit, and that's it. That's the entire unit. It's got all of the refrigerant-containing components. It's got the fan coil. It's got, in many cases, the controls are like right here on the unit itself. So there are some advantages to this. One, it's very low first cost, and often these are sized for doing room by room heating and or cooling, and so you can control them room by room. Some of the drawbacks to a package terminal heat pump is that they tend to be pretty low efficiency. They're sort of at the very bottom of the efficiency curve of heat pump systems. They are also noisier than split systems. So in a split system, which we'll see in a minute, you remember when we saw the compression cycle or the refrigerant cycle, part of it is a compressor. And a compressor has got to rotate, and it's going to make a certain amount of noise. Not a ton, but some. And in a package terminal heat pump, that compressor is inside of this unit, which is inside the apartment. So you have some amount of noise, and which we've all experienced. You know, if you've been to a motel or a hotel that had a unit like this, you turn it on and it goes, you can hear it, right? So we've all sort of experienced that. And they take up interior floor space. So again, if you think to an experience you may have had with these, they do kind of stick out into the room a certain amount, and they tend to be located down low where you can operate them. And so that takes up a certain amount of interior floor space. One really important distinction, if you are looking at package terminal heat pumps, is that you will see PTHP and you will see PTAC, or PTAX. You want to always look for a package terminal heat pump, not a PTAC. PTACs and even some package terminal heat pumps may have electric resistance heat built into them. And so, like, from the same manufacturer in the same form factor, they may have a PTAC with no heating. They may have a PTAC with electric resistance heating. They may have a package terminal heat pump with electric resistance, like additional heating, and they may have a package terminal heat pump with no additional electric resistance heat. And in order to make sure we're getting the full efficiency out of this unit and we're actually realizing the potential efficiency of a heat pump, we want to make sure that we stay away from the electric resistance heating. Otherwise, you're just getting a a really expensive electric resistance heater that also can air condition sometimes, right? We want to get that full heat pump efficiency. So you want to try to avoid the units with electric resistance heat. And sometimes the manufacturers don't always make it very easy to do that. I've seen cut sheets that can be very confusing where you think you're like, oh, we got the heat pump. And it's like, whoop, little electric resistance heater built in. And you have an option to not do that. And you just have to be careful. So that's package terminal heat pumps, or PTHPs. They're very low first cost. So we do see these in quite a few projects for cost reasons specifically. Another type that are not as common in apartments, but we're starting to see them in some, and probably where folks may have encountered these are in like hotels, are called vertical terminal heat pumps. They're usually abbreviated VTAC, which would stand for vertical terminal air conditioner, but often these can be specified with a heat pump unit. And again, they can have backup heat or not, and so you have to read very carefully. So these are a self-contained through-wall unit, just like the PTHP, where this will be inside and then this would be outside on the outside of the building. But these do actually have a very short duct run. So what you'll see often is these are in a closet where you have the air intake here, this duct goes up, and then it dumps into the room, at the top of the closet. So they're technically not entirely ductless, but it's an extremely short duct run. So advantages of these, they are also quite low first cost, and you can have room by room controls. There's also potential in low load scenarios where you could duct this to one room and another one, and so they have that built into them. So technically not ductless, but it's not a fully ducted fan coil like we usually think of. Some of the drawbacks to these, they also, like PTHPs, excuse me, tend to be fairly low efficiency heat pumps. And you do, because you have some ducting, you do get some duct losses. And they also take up interior floor space. This is a unit that goes through the wall, extends into the room, and they're usually put into a closet. There's like a sort of a framed out area that these are enclosed in. So another note, similar to the package terminal heat pumps, many of these VTAC systems with heat pump heating also have electric resistance backup. So you need to be sure when you're specifying these or when your engineer is specifying them that they are sizing them based on the heat pump heating capacity, right? The heat pump may have, 20,000 BTUs of heating capacity, and then they've got an electric resistance coil with another 20,000. Well, if 20,000 is not enough to meet the heat demand for the apartment, then they should specify a larger heat pump so you can meet the heating demand of the apartment with the heat pump and not have to kick into electric resistance mode because you lose all that efficiency from the heat pump itself. So again, very similar in sort of some of the considerations to a package terminal heat pump, but a different form factor, and one that we haven't seen on a ton of multifamily, but some, and we're starting to see it pop up here and there. So I wanted to mention it. A third type of packaged system that is really just starting to enter the North American, particularly the US market, is a room heat pump, or AC. This is also like a package terminal heat pump, a self-contained through-wall unit. But unlike a package terminal heat pump, the exterior, and unfortunately I don't have a good photo of this, but the exterior penetrations, let me see if I can actually draw, I think I can. So on the back of this, what you'll have is you have two penetrations. You have like an in and an out. And so it looks kind of like a direct vent wall furnace in terms of the outside of the building, where there's just either two or one where they sort of go bi-directional. So you're not having to cut like a giant rectangular hole in your wall like you would for a package terminal heat pump. You're just cutting enough space to get the air intake. So it's still pulling in outside air and using that to either pull heat from or dump heat into, but the actual penetration is much smaller. So advantages of these systems, they're also quite low first cost. They have smaller penetrations than a package terminal heat pump, and this is a huge advantage. They run on single phase 120 volt power. So these can, depending on your local building codes and requirements, they can be directly plugged into a wall outlet. which could be really ideal for retrofits. Some drawbacks, these are relatively new to the US market, and they have smaller capacities. So you're not going to get a 40,000 BTU one of these. These are appropriate for low load applications, which if you're doing a major renovation or you have new construction, you have a good envelope, and maybe you're dealing with smaller units like studios or relatively compact one bedroom apartments, do the sizing calculation and these might work out for you. And they could be a really great solution for a lot of projects. So that covers the packaged system types. Before I move on to split systems, Matthew, are there any questions about the package systems that have come up?
I do indeed have a few questions here. So the first one is just about, do you have experience with different types of these room heat pump slash ACs? Do you have different suggestions on brands to look into?
So the one brand that we are familiar with is called Innova, Innova. And we actually, AEA is sort of separate from the ORMAP program. We're actually having an info session in our office here in the Bay Area, hosted by Innova, sort of talking about this unit that they have. And we have some installed in a couple retrofit projects here in the Bay Area. So Innova is the one that I'm familiar with. There may be others. But again, they're relatively new to the U.S. market, and so that's sort of the extent of it for now.
Yeah, great.
They've been
And
available
then,
they've been available in Europe for quite a while, but they're just starting to bring them to the United States.
mhm. Yeah, and that presentation from Innova in California that you referenced is available through webinar. So
Yeah, it is. So anybody can join the Zoom invite. So I can, Matthew, I can make sure that you have that link and you can send it around to the folks who attend this.
great. Yeah, and then the next question I think pertains mostly to the PTHP, the through wall, is if you have any additional air sealing details or suggestions for that unit as it goes through the wall.
Yeah, so these are going to have a sleeve that goes into the wall, and then the unit goes into the sleeve. I mean, yeah, you do have to air seal it. This is something that comes up on projects, and you just have to be careful and look at your details. I don't have any specific details handy for doing that. That's usually something that the architect covers. But the manufacturer should have some resources for you. They should be able to point you to maybe some language about where you seal and what you seal with, or some best practices. So I would suggest contacting the manufacturer's rep and asking them about, like, hey, what's the best way to air seal around these units? What you don't want to do is air seal the unit itself to the wall, because if you ever have to replace it or take it out, it's like the sleeve is, I think, what you generally want to air seal. But I would say talk to the manufacturer. That's the main thing.
Yep, great point. That's the two questions for now. Thanks.
Okay, great. So now let's move on to split systems. And there are two major types of split systems: ductless mini splits and variable refrigerant flow. So we're going to start with ductless mini splits. Ductless mini splits are probably, when people think ductless heat pumps, often this is what they're thinking of: a ductless mini split heat pump. And so these have a few components. They have an outdoor unit, which will look something like this. They have anywhere from 1 to 4 indoor units, which could look like this or could have other forms. And then refrigerant lines running between these units, as well as there's a power line too. They're often sort of all bundled together. So what are the advantages of ductless mini split heat pumps? These are inverter-driven compressors, or these have inverter-driven compressors, which means they can vary their speed to match the load. So if it's a cool day and the apartment just needs a little bit of heat, the compressor can turn on, 20, 30%, run at a relatively low speed, and get significant efficiency improvements relative to a system that only turns on full speed and would have to turn on full speed for like a minute and then turn off because it heats up the apartment so quickly. These are designed to ramp their speed up and down and sort of simmer the heat pump at a low speed to maintain a consistent temperature all the time. and that comes with significant energy benefits and efficiency improvements. Like I mentioned earlier, these can have room-by-room controls. So the most common design strategy is to have one outdoor unit and then an indoor unit in every room. So that could be each of the bedrooms and then one in the living room. There's often the living room is connected to the kitchen, and there's usually not one of these units in the kitchen. Sometimes there are, but it's usually living room and then every bedroom. So then you have that room by room control. Some of the drawbacks for these units is that you're going to have to locate an outdoor unit somewhere. I mean, that's kind of the case for any heat pump, right? Even the packaged ones, you have to put them on an exterior wall. So you're effectively having to find some outdoor wall space to put them on. It's just going through the wall. These are outside. So these would need to be, and they also need to be mounted somewhere that's accessible so they can be serviced and maintained. So often we see these put on, let's say if there's a porch or a balcony for every unit, that's a great place to put them. If you go to other countries, say in Asia, you'll just see these all over the outside of every building. And they've decided that they don't mind the way these look. Some people feel like they are ugly and they don't like looking at them here in North America, but I personally I've gotten over that. I think we'll get over looking at certain things like windmills and heat pump outdoor units when we realize that like these are effective solutions for meeting our energy needs. Another drawback is that sometimes when we're dealing with an apartment with lots of bedrooms, let's say a 3-bedroom or 4-bedroom or like 5-bedroom, which I've seen on a few projects for family housing, the cost of these indoor units can add up. And so one thing that I've seen on a number of projects, particularly new construction, is they say, okay, we want to do these mini split heat pumps with the inverter-driven compressor outside. And for a studio and a 1-bedroom and a 2-bedroom, they've gone with a ductless mini split, just like this, with one of these indoor units in every bedroom and the living room. And then once they get to like 3, 4, 5-bedroom, they've actually found that it was cheaper to go with a ducted system, like a ducted mini split. So instead of this one indoor unit in every room, they'll go to a ducted fan coil, still powered by this inverter-driven compressor outside. They'll do a ducted fan coil because at that point, the cost of having 4, 5, 6 of these indoor units is more than the cost of one ducted unit inside and then running the ductwork and softening to the different bedrooms. So sometimes there's like a cost tipping point with a number of apartments. So that's something to look at on your project and to think about. Maybe it makes sense to have a ductless mini split in certain apartment types and then a ducted system in other apartment types. And the ducted system, it's still inverter-driven compressor, so it's still going to be quite efficient if it's using the same technology as these. And all of the manufacturers, Fujitsu, Mitsubishi, Daikin, Hitachi, all of them that make a ducted mini split system like this also make, all of them that make ductless mini split systems like this also make ducted fan coils that you can duct to different spaces. So you can have just one, you can have all Fujitsu, you can have all Daikin or all Mitsubishi, and some apartments will get these and some apartments might get a ducted fan coil, and that can be a solution that works for projects. So that's on a unit by unit level. So you'd have one outdoor unit per apartment or maybe per common area space, and then some set of indoor units. Sometimes, though, it makes sense to do things centrally. And for that, you would go with what's called a variable refrigerant flow, or VRF system. So the components in a VRF system are very similar to a ductless mini split. They have an outdoor unit, which will be something like this, and then you can have a whole ton of indoor units, sometimes upwards of 40 plus. You have refrigerant lines running between all of these, and then control boxes. So you have these boxes that are controlling things. Some advantages to a VRF system. These are super efficient, and especially if you have a building where you're going to have simultaneous heating and cooling. So let's say you have a building with lots of solar exposure, lots of glass on like the south and west sides, but you're in a relatively cool climate. Those south and west facades of the building in the evening and afternoon, they might need air conditioning, whereas the rest of the building might still need heating. And if you can connect those areas that need heating and that need cooling to the same outdoor unit, what it will do is instead of doing heating and cooling for each of them individually, it's going to move heat from one zone to another. And that is an extremely efficient way to deliver heating and cooling to a building, and you can get extremely high efficiencies out of these. You also just have one outdoor unit. Just this one unit here can serve a whole ton of different spaces. So a new construction project of ours in San Jose recently completed last year with a VRF system, actually the same system here from Daikin. And for like I think a 60 unit apartment building, I went on the roof and they had, I think, 5 outdoor units. And if you think about the number of outdoor units that you would need to have an individual mini split outdoor unit for every apartment, you'd have 60 of them. And instead they had 5 of these. And these are about the size of like I would say like a luxury refrigerator, like a proper mansion refrigerator, but a refrigerator nonetheless. They're not, gargantuan. And I was just amazed at how much roof space they had. So that's a major advantage of these is you have a lot less space taken up outside. Some of the drawbacks, these are central systems. So all of these spaces are on a single outdoor unit. So it can be challenging to submeter tenants for their energy. Like if each of these indoor units represents a separate apartment, there are systems from manufacturers of these VRS systems. There are ways to submeter based on the refrigerant movement through the system and bill for heating or cooling usage, but that's just sort of like an extra step. And there's like there are billing services to do that, but it sort of introduces complication. And VRF systems tend to be higher first cost than either a ductless mini split that's done unit by unit or any of the package systems. These tend to be one of the highest first cost systems. But if you have a project where, let's say, it's supportive housing and the owner is just going to be paying for the heating and cooling regardless, and it's studios, so you have very small units, and you're going to have you can have a lot of units on a single central system. This could be a really effective solution. You might not need very much roof space at all to get kind of all of or a significant amount of your heating and cooling outdoor unit sort of all under one piece. So they make sense for some project types, but not all project types. But I wanted to put them out there as a possible solution. Okay, any questions about either of those split system types?
No questions on either of those systems, but we did have a question just asking about if this presentation will be available online afterwards. And yeah, it'll be posted on the ORMAP website right after this presentation is over. And then also, if you want me to just email it, reach out through the questions box, and I'll make a note to contact you through email.
Okay, great. All right, so we've talked through the different system types. Let's talk about decision making, right? So what are the things that we need to be thinking through on each project to figure out which of these systems we should even be considering and which might be the best fit for our project? So we could start with the size and layout of the property, right? When might it make sense to go for a split system versus a package system? If every apartment has its own balcony or sort of outdoor patio, you've got a lot of area, I would say you should start with going with a split system because you have space for the outdoor units. You have the room for them. Really, a patio or balcony is an ideal place for a compressor because it's part of the apartment, but it's also relatively accessible and it's outside. For a package system, maybe if you don't have patios and you have a taller building, and so where you would locate the outdoor unit for upper units or lower floor units might be tricky. you might consider going with a package system. And then if you want to do a split system, but you have a very tight site and it's a taller building, and you have very small units, maybe the VRF system would work because you have a smaller number of outdoor units to serve the whole building. In terms of zoning, we talked about being able to heat and cool, individual rooms, and that means you have a different zone for each room. And in some cases, like we discussed on the ductless mini splits, that can mean more cost, especially as you get into higher number of bedrooms. And so just keep that in mind that it may not be that you want just one system type for a particular project. If you have a mix of different numbers of bedrooms in your project, you may end up going with one system type over here and another over there. So just sort of keep in mind that being flexible on a project can deliver a solution that's really optimal. In some cases, you might even be able to get away with having for example, a package terminal heat pump in a living room, and then and that could deliver sufficient heating and cooling for the whole apartment. But you have to have some way to get that heating and cooling into the bedroom. And so that can be done with transfer fans. Are these ideal? No, but they can be a very low-cost way to effectively deliver the heating and cooling to the whole apartment with a single low-cost unit like a package terminal heat pump. So, think about that. And also then you could think about, well, if we do a vertical terminal heat pump, that already has a short duct run built in. We can have, one register in the living room and then just 90-degree angle, put it adjacent to the bedroom, and have the other register go into the bedroom. And then you don't need the transfer fan because that is all built into the unit itself. So think about that when you're looking at some of these lower cost options and like, okay, how are we going to get heat everywhere? Do we really need a unit in every room? Maybe you don't, and there's a lower cost way to get that heating or cooling to the other zones. Retrofit versus new construction. This question comes up a lot. Like, what's a better approach? And there's really no answer to this. It is going to depend on your project, on the specifics of your project. What the priorities are for the owner, for the occupants, for the building operators and property management. There's not one answer. You'll really need to think about each of these considerations for your specific project. In terms of maintenance, we'll get into maintenance on the next slide. And then finally, in terms of cost, we need to remember that there's more to the cost of a system than just the first cost. There are first costs, there is also maintenance costs, and there are lifetime energy costs. And keep in mind that the lifetime energy cost is, in most cases, going to be borne by the tenant, by the resident. And often, first and maintenance costs are sort of at odds with energy cost, and they sort of pull in different directions, which can be tricky to balance. So let's look at some of a comparison of some of the more popular systems in the ORMET program. So in this table, we have 3 columns. We have this column here for electric baseboard and wall heaters. This is just electric resistance heating. Then we have packaged terminal heat pumps, those very low cost through the wall package systems. And then ductless mini split heat pumps, super high efficiency individual heat pump for each unit with potentially an indoor unit in every room. So in terms of the efficiency rating, electric resistance is extremely inefficient, right? It's poor. It's not good at all. Packaged terminal heat pumps, they're pretty good. And then ductless mini split heat pumps, very good. That's sort of the best efficiency you can get in a heating and cooling system. The useful life of these systems, electric baseboard wall heaters, literature says 20 years, but anecdotally, we've probably all seen an electric heater that is like 50 years old that is still working. So in my experience, electric wall heaters can last maybe as long as they don't get kicked in and destroyed, potentially forever. Not forever, actually, but a long time. They last a long time. There's no moving parts. They're pretty bulletproof. Packaged terminal heat pumps in general have a rated useful life of 15 years. So that's sort of the standard assumption. And the same goes for ductless mini split heat pumps. Around 15 years is the assumption. which of these actually provide cooling? Remember, an electric baseboard or wall heater is not going to provide any cooling. So if at some point you decide you need cooling in your building, you're going to have to install a whole separate system for that. Whereas a packaged terminal heat pump and a ductless mini split heat pump system are both going to have cooling built into the system. Energy savings, electric resistance, you don't get any energy savings. You get energy penalty. I mean, they're terrible. They use tons of energy. Packaged terminal heat pumps will save you some energy relative to electric resistance, and ductless mini splits even more. How about costs? So the install cost, they really from left to right go from cheap to moderate to more expensive. Ductless mini splits having the sort of highest install cost, electric baseboard having the lowest install cost. One thing that is often not included in the install cost and that maybe we should think about is actually the electrical load requirements. So to heat a space with electric resistance that's operating at an efficiency of 1, you're going to need a certain amount of electricity. To heat that same amount of space with a heat pump that's operating at 3 to 5 times that efficiency, you need less electricity. So therefore, your electrical service for both your building and for your individual apartment could be lower with a heat pump heating system than with electric resistance. So when we're looking at our install cost for a building or for an entire project, we should make sure that what we're looking at includes not just the cost of the equipment itself, but like, hey, are there savings on my electrical service or my electrical panel by switching from electric resistance to a heat pump system? There might be, and it's worth looking at. In terms of maintenance costs, electric resistance, there's almost no maintenance. Things break occasionally, but not very often. Packaged terminal heat pumps and ductless mini split heat pumps, they have moving parts, they have compressors. In some cases, they will all have a condensate drain. In some cases, if they're not able to drain that via sort of gravity and slope, they may include a condensate pump to get the condensate out. That's another moving part that can break, so there is maintenance and upkeep associated with that. And then we get down to what the tenants actually see, which is the lifetime energy cost. This is what they see on their bills, and for electric resistance, it's definitely going to be very high because they're so inefficient. Packaged terminal heat pumps going to be less, more efficient, and then a ductless mini split, the lowest and most efficient, lowest cost system to operate for the resident. Okay, we got another question break. Anything that's come up?
Currently, there are no questions.
Okay, we can move right along to controls. So ductless heat pump controls come largely in 2 varieties. There are manufacturer-provided controls like we see on the left, and third-party controls. So we'll start with manufacturer controls because every system is going to come with some variety of manufacturer control. And these generally take one of 2 forms, either a remote control or a wired thermostat. So the remote control has a thermostat on, like it is sensing temperature, but it functions like a remote control. So it is wireless. It's going to be just controlling the unit in that room. A drawback of these is that they are battery controlled, or battery powered, excuse me. So you need to maintain the batteries, or somebody needs to maintain the batteries, the property management or the resident. And because it's a remote control and it's not glued to the wall, it can and therefore will get lost. Not all of them will get lost, but there will be some number of these that disappear or get broken or whatever. But these tend to be the controls that come with the unit standard, and you don't have to pay anything extra for the remote control. Wired thermostats are often another option for these ductless heat pump systems. So a lot of them will provide an option for this if you choose to specify it. Sometimes they can control multiple units. So there was a question of, do you control it one room at a time, or do you control it centrally? And for some of these wall-mounted systems, or wired thermostats rather, they can control multiple indoor units. For these, you don't have to maintain batteries. So that, to me, that is a major advantage because, and it's wall-mounted. So a wired thermostat, for me, feels like more resilient to just the stuff that happens in an apartment. In people's homes, things happen in housing, and So I feel like a wired thermostat is a more durable approach that may be less likely to have to be replaced. But even a wired thermostat, things can happen and they can break and people can break them, and so you may have to replace them. But it's not like someone can just take it off the wall and accidentally throw it in the garbage can or something. So those are the two basic types of manufacturer controls: the remote that tends to come with the unit, and a wired thermostat, which could be an optional upgrade for some units. There's also the option of going with some variety of third-party controls. So these could be things like the Nest, which lots of folks have heard of, as well as Ecobee, which is a great one that we've used on some projects, as well as products from control manufacturers that people have heard of and worked with for a long time, like Honeywell. These third-party controls are highly customizable. They tend to have a pretty user-friendly interface. Sort of take a look at the screens here, particularly like the Nest, where it's just a number and a dial, very easy. And then let's go back to these remote controls, particularly like the ones on top with like a million buttons. Some of the manufacturer controls I feel like leave a little bit to be desired in terms of user friendliness. They're getting better. Like this Amana one down here. That's not too bad. That's pretty basic. People should be able to figure out how to operate this. But this is getting a little complicated. And I've seen ones that have like 5 times more buttons than this. So I think some of these could use a little bit of simplification, which the third-party controls, because like nobody has to install a third-party control. You choose to buy these if you want them. And so if they're not user-friendly, nobody's going to buy them. So these tend to be quite user-friendly. However, they do require Wi-Fi. And they do tend to be the most expensive option in terms of first cost, right? You're often going to have to pay extra for these. They're not going to come with the system, and you'll have to make sure that it's compatible. These manufacturers of these third-party controls they're in the business of being compatible with everybody else's equipment, so you can install them. But you still have to, they have to be installed. They have to be set up and configured. So it's a little bit more of a process, where the manufacturer controls out of the box, you plug it into the system and it just works. But these, once they get set up, can be very user-friendly and easy to operate. And in some cases, there have been studies showing that they result in significant energy savings from a smart thermostat like this. So when you're thinking about controls for a ductless heat pump system in your project, just think about a few things. First, simpler is usually better, right? Particularly, these are apartments, often with folks who have a lot going on in their lives, and they're not probably very interested in spending a lot of time learning how to use their complicated thermostat. So if we can have simple controls that are easy for tenants to operate, they will be happier, and then property management will be happier because they're not having to go into people's apartments once a week and help them figure out how to change the temperature or turn on or off their heating and cooling system. Another consideration is that hardwired controls may cost more upfront, but they may also be easier to maintain down the line because they won't require a battery. So battery controls, again, they tend to come with the units, particularly the mini splits. But in my opinion, if you can find the budget for it, I would suggest bumping up to a wired control. Regardless of what kind of controls you go with, it's a good idea to train residents on how to operate them. And we've seen folks have success when they provide quick reference information. So you can give them the manufacturer, literature. They're just going to put it in a drawer if they don't recycle it immediately. Hopefully they recycle it. What we've seen folks have success with is to actually make a one-page, laminate it, or like a half page, where they have a picture of the control and then arrows labeling what buttons do. This turns it on, this makes it hotter, this makes it colder, this switches it from heating to cooling, and post them on the wall next to the controllers or next to the thermostats in people's apartments, to try to answer the common questions that people have. So that some buildings have had success with things like that. So that's what we've got for ductless heat pump systems and controls. Are there any final questions?
Yeah, I have one question that I think is pretty interesting. It's about do those third-party smart thermostat controls allow for uh, recording of data from the units?
Some of them do. Yeah, some of them have. A lot of them have because they operate via Wi-Fi. A lot of them have the ability to sort of connect to data interfaces. So yeah, there is the ability to do that. I know that we are doing a research project right now with apartments that have the Ecobee installed, and I think we're using the online interface, and they've given us access to it, and so then we can pull set point and like usage data off of this.
Yeah,
And
very interesting.
I would assume the Honeywell and Nest do too. And really, anything that can be connected to an online interface likely has some ability to collect data off of it.
Hmm. Yeah, great. And that's it for now. If anybody has any further questions, please type them into the question box or feel free to raise your hand if you want to speak up. So I'm not currently seeing anything. So with that, thank you, Nick. I really appreciate that. There's a lot of great information in there. Um, you can reach Nick through the email on the screen or go through me if you have any outstanding questions. We'd be happy to help you out.
Yeah, thanks, Matthew.
Hmm. All right.